Good morning. Hi everybody. Today I'm going to tell you what our experiment is. The research question that was put forward by our teacher was, how does the ratio of surface area to volume affect thermoregulation? This can be seen in many animals, especially elephants, with their huge ears that are almost a meter long are there to increase surface area and allow elephants to reduce their heat during the night quickly. But what is our experiment is the question. Well, what we've had to do is, with Lego blocks, create a square with a 1 centimeter hole in the middle, full with 30 degrees of water. Yes? This will be the constant volume for every trial. What we will be changing is, in order to affect the volume to surface area ratio, is the surface area which surrounds a 1 centimeter hole. So, we'll see how it goes. Our hypothesis is, if we increase the ratio of volume to surface area in favor of volume, meaning that there will be a great amount of volume than surface area, then the temperature change will be smaller. This is because a huge volume of water will take a large amount of time to cool down, and especially if there is only a small surface area from which the water can escape from. Not to explain this better, here are some examples. If the volume is 2 centimeter cubed and the surface area is 1 centimeter squared, then the 2 centimeter cubes of water only have a small amount of air to escape from, and the amount of water connecting with the outside world will be less.
Our independent variable is the amount of water poured into the container, and the dependent variable is the temperature change. We will manipulate our independent variable by pouring different amounts of water: 300 milliliters, 500 milliliters, and 700 milliliters.
The first controlled variable will be starting temperature of the water, which will be 40 degrees. The reason we must maintain this is because if we constantly change the original temperature, then the water will cool down faster or slower. For example, if the starting temperature is 100 degrees, then the water will cool down much faster because the surroundings are much colder. Yet if the starting temperature is 30 degrees, then it will cool down less. How you will maintain this is by always keeping and heating up the water to 30 degrees.
Another controlled variable is the material of the container. If the material of the container is changed, then the results will change because some materials insulate and others insulators will keep the temperature longer, while the conductors will lose temperature faster. We will do this by always using the same container made out of plastic.
So another control variable we have to take into account is the starting temperature of the container, because if we have a lower temperature or a higher temperature, because if the container has a higher or a lower temperature, then that can affect the rate in which the water cools down, or the time in which it takes for the water to cool down. We're going to control this by making sure the container is always in the same temperature. If it gets too hot, then we're just going to need it to cool it down a little bit, and if it's too cold, well then we'll just heat it up a little bit until it's on a constant temperature for every try.
The fourth controlled variable is the type of liquid we use, in our case, water. The reason we don't use liquids such as milk or juice is because they are much denser than water and therefore lose heat much slower. So in order to keep this experiment correct and accurate, we'll always use water and the right amounts.
So the final variable we have to control is the time it takes, is the time in which we're going to measure the temperature. So we have to control this because if we measure the temperature after different amounts of time, then the results may vary because of course after a certain amount of time the water loses certain heat or gain or doesn't. The thing is that we have to always keep the same time to have concrete results. We are going to control this by waiting 2 minutes after the water is poured to measure the temperature of the water.
Heat up 300 milliliters of water to 40 degrees using a Bunsen burner. Make sure it's 40 degrees by using the thermometer. Pour the 300 milliliters of water at 40 degrees to the plastic container. Start the stopwatch, and after 2 minutes, record the temperature by using a thermometer. Calculate the temperature change by grabbing the initial temperature and subtracting it from the final temperature. Repeat the process 4 more times, making sure you just did 5 trials for 300 milliliters of water. Repeat the process for 500 milliliters of water and 700 milliliters of water, making sure you calculate temperature change and do 5 trials for each amount of water.